5 different PET CF filaments from different brands, and then we have direct comparison in this video. Welcome to my tech farm. I already mentioned several times that PET CF slowly became my favorite filament type, and we are talking about technical filaments. Why only now? Well, if you are new in 3D printing, then maybe you don't remember of those times, but 3-4 years ago, the Teflon line hot ends were dominating on the market with the maximal print temperatures of 240 degrees Celsius. If we upgrade to the Capricorn tube, then we can go up to 260 degrees Celsius. And only nowadays, those 300 degrees Celsius became some kind of standard with 3D printers. Some of them can go even higher. Here is a small list of important 3D printers which can go even higher, above 300 degrees Celsius. Unfortunately, I can see that some companies goes in opposite direction. For example, with Prusa Mark III, I could go up to 300 degrees Celsius, but with Mark IV or Core 1, the maximum nozzle temperature is 290 degrees Celsius. And even the, for example, Filament PC CF blend can benefit from this extra 10 degrees Celsius. I already tested it. We have much better layer adhesion if we print it on 300 degrees Celsius. Just in case if you're not familiar, don't mix these materials with PETG, that's glucose-modified PET. With these, the print temperatures are lower, but also some mechanical properties and temperature resistance is lower too. About printing on open printer. Some companies claim that it can be printed without any problems. Some other companies claim that yes, it can be printed, but in that case the layer adhesion will be reduced because of that faster cooling. But in this case, this will be tested too. This is not a sponsored video. 3 of these filaments were sent by the companies. 2 actually I bought myself because, for example, Qidi don't promote filaments. And also the Phaetus, actually this was a request from my Patreon supporters. And this cost me $170 because shipping from the US costs more than 50%. And you may be thinking, how is this possible? If you're not familiar, I don't have sponsors. An important update, that intro I recorded much earlier. In the meantime, the Polymaker became a channel sponsor, but very important deal of our agreement is that this don't have any kind of effect to my measured results. Back to the video. I don't have ads during the video, and my videos are not really recommended by YouTube algorithm, and approximately my cost earnings from the YouTube ads is around $10. But thanks to my Patreon supporters, these kind of videos are possible too, so big thanks to them because they keep this channel alive. Let's take a closer look of the spools. This is BambuLab and it has the lowest recommended print temperature, but I want to use the same G-code, so I'll try to print even this one on 300 degrees Celsius. If it will not work, then I will lower the temperatures. Polymaker PET CF17, this is from that Fiberon line. This is Phaetus PET CF with recommended print temperatures between 280 and 320 degrees Celsius, like for the rest of the filaments. Siraya Tech PET CF. Qidi Tech CF, which also contains 15% shop carbon fibers in it. An interesting thing I noticed only now, look how similar are these two spools. Maybe they are manufactured on the same place, or maybe it's just a coincidence, but this could explain why Qidi don't promote filaments. Maybe it is just a rebrand. I'm not sure. Now let's talk about annealing. According to my experience, the mechanical properties are not changed significantly after this process, but where the annealing really helps, that's the temperature resistance, and this will be tested in this video. Most of the testings will be done with non-annealed versions, because this is what I'm curious about. And I will not have here those regular testing methods, because each of these filaments have their own review video. Here I want to have some different experiments, things which I'm curious about. These are the test objects from this video. For the layer adhesion test, I will have these printed with 2 volts and 20% gyroid infill. Smallest cross-section area is 10 by 10 mm. All other test objects are solid inside, printed with maximal number of the valves. I will have these 2 hooks, one of them will be annealed. For the bending test, the object is same like before, but I will use different equipment. 64 mm is the distance between supports. For the temperature test, I will have 2 objects and one of them will be annealed. For the creep test is the same test object, but I will use a little bit different weight. I don't want to use 1.25 kilograms, lighter or heavier, at this moment I'm not sure, and these 2 are for the tensile test. And I'm using BambuLab PET CF profile for every printing, and only one thing I changed, and that's the nozzle temperature to 300 degrees Celsius. and I will use the same settings for all 5 filaments. For real-time application, I decided to print these corner brackets for the 2020 alloy extrusion. I can have never enough from these, and these can be printed without supports, only this bridging is very critical, and I want to measure how stiff are they. Each of them will get a long drying. They are sensitive to moisture, and one of the checking methods is to print some small box and measure it. If it is bigger, like over extrusion, probably the filament needs drying. It's bigger because of those micro water drops inside the nozzle. They boil and push out more material. Just to present you how important is the drying, this is PET-GF. Wet state, actually it was stored 1 month in resealable bag and I thought it would be okay, and after the drying this is the result. This is over extruded and the dimensions are also bigger, and look at that ugly surface. Each of them got extremely long drying, and I am starting in ABC order, BambuLab. All test objects at once, perfectly straight objects, no warping. And this is that corner bracket. Next filament is Phaetus, and it's still hot from the dryer. As I mentioned earlier, I'm using exactly same settings for all 5 printings. The next is Fiberon by Polymaker, PET CF17. And again, the same G-code. Next one in ABC order is Qidi Tech PET CF. The printing is at 70%. And the last one in the ABC order is Siraya Tech PET CF. Siraya Tech, and it will be finished without my supervision. I wasn't even here. Yes, perfect printing every single time. Just in case, I label them. Only on this bracket from the BambuLab I noticed that bridging didn't come out nice. In every other cases they are perfect. But this is the only filament where the default settings is 270 degrees Celsius, but I printed everything on 300, much higher. So I decided to reprint these test objects from the BambuLab using the default settings. This is the bracket, printed on 270 degrees Celsius. But also I want to check the layer adhesion, how much weaker will it be if I print it on lower temperature. Layer adhesion test objects are reprinted on BambuLab A1, which is open printer. I'm printing a small storage box. If there is any warping or cracking, it should be visible on this one. 20 more minutes of printing. It's completely okay, and even the side surface looks nice. Bed adhesion is good during the printing, and when it cools down it is removable. This is Polymaker PET CF. No signs of the warping. And this group is finished and labeled, ready for the testing. Only these test objects will be annealed. These are hooks and these are for the temperature test. The annealing will be done on Sunlo E2 filament dryer. Temperature is set to 100 degrees Celsius and these are small test objects, 2 hours should be enough. They cool down together with the dryer. The price is very important. Now they have different spools, but I calculated the price for 1 kilogram using their best offer. The BambuLab is most expensive, then Phaetus, and the rest 3 are very similar. Filament bending test immediately after the drying, but I was waiting until it cools down. This is BambuLab, start angle 30 degrees. Maybe 80, but I will check the footage. This is Phaetus, and in every case I was waiting 15 minutes after I took it out from the dryer to cool down. Polymaker Fiberon. The most flexible so far. Qidi Tech. 75. And Siraya. The most brittle filament. Around 70, but I will check the footage. I'm not sure how important is this data. For me it's enough that in all 5 cases they are above 30 degrees, because I noticed that below this value it's too brittle and it may break in some Teflon tubes if bended too much. I will start with the layer adhesion test. These are all printed on 300 degrees Celsius except this one, BambuLab, which was printed on 270 degrees Celsius. It is good to see that BambuLab printed on default settings is not much weaker compared to the printing on 300 degrees Celsius, but basically in all 6 cases this is a good layer adhesion. Still the layer adhesion, but these are printed on BambuLab A1 on Open Printer. And one thing I noticed on Open Printer, I don't have so constant results, but we will find out that soon. Interesting, only BambuLab claims on their website that printing on Open Printer will result weaker layer adhesion. Looks like they really know their own filaments. Far the strongest is the Phaetus, and the rest 3 are very similar. Well, after this I want to recheck if I can get again that layer adhesion with the Phaetus filament. So I'm reprinting those test objects for the layer adhesion using the exactly same G-code. There is one big difference between these test objects and the previous one. These are printed after the filament was on open air at least 10 days, and the previous one in all 5 cases was printed immediately after the drying. Phaetus PET CF, second time. Still close to 60 kilograms, so it was not a coincidence. Tensile test, these are printed in horizontal position, and the smallest cross-section area is 4 by 4 millimeters, and they are solid inside. And of course again I am measuring the break load only. I checked the review videos too and I got similar results. Polymaker is the weakest. About the Phaetus actually I don't have the review video, and the rest 3 are above 100 kilograms even there. Hook test, and these test objects has some tensile and bending stress too in the same time, and this group is not annealed. These are annealed hooks which are recorded later, but in the video I will place them side by side so you can see the effect of the annealing. On this graph we can see annealing didn't really change the mechanical properties of these hooks. In most cases it's even weaker a little bit, except with the Polymaker. Here we can see some improvement, but the difference is negligible. Creep test the deformation under constant load. The load will be 1.5 kilograms. This load is bigger than my regular testing, but this material resists good to the creeping, and I hope I will see bigger difference between them. I already measured them. This is the distance between 2 reference surfaces. BambuLab, Phaetus, Polymaker, Qidi, and Siraya. And I will not measure them every day, so let's jump in a time. This is day 5, I already measured them. Now I didn't measure them every day, but visually I could notice some deformation only on day 1. After this I couldn't notice any additional deformation. This means they really resist good to the creeping, but let's analyze the numbers. Yes, first let's remove the load. And the permanent deformation is almost equal and basically close to the 0. Blue is the initial deformation and orange is the deformation after 5 days, and difference between 2 is the yellow point, that's the creeping. We can see the Polymaker had the biggest deformation, but interesting smallest creeping, the difference between 5 days, but all 5 materials resist great to the creeping. Just for reference, average ABS with a smaller load of 1.25 kg, which is my regular testing, would be somewhere here. Impact test, this is not a real advantage of these materials, and these are a little bit thicker test objects, so hopefully I can see some bigger difference between them. BambuLab, Phaetus, Polymaker, Qidi, Siraya, From the angle I calculated the breaking energy in joules. We can see some difference here and there, but more or less these are very brittle materials because of those carbon fibers. 3-point bending test, and distance between supports is 64 mm, which follows better than the ISO standard. Also these supports are rounded, the diameter is 10 mm, and I will place 5 kg load and I will measure the deformation after exactly 30 seconds. BambuLab, Phaetus, Polymaker, Qidi Tech, Siraya. This is not a big load for these materials, and I already checked each of them is perfectly straight. And very similar ratio we could see with the creep test. BambuLab has the smallest deformation, Polymaker the biggest, and rest 3 are very similar. Temperature test in the oven. 5 on the left are regular and 5 on the right are annealed, and both in ABC order. 5 samples on the right didn't start to deform at all during this experiment. 5 samples on the left did begin to deform, but at different temperatures. However, the deformation stopped shortly after it began. You will see later in the video, I think this happened because they became annealed. Once crystallization occurred, the deformation stopped completely. I stopped the experiment on 226 degrees Celsius, and the annealed version, for the filling they are completely hard and without deformation. I also checked regular materials, and for the filling they are equally hard. Probably they became annealed at the beginning of this test. Corner bracket test, and this is the first time I will do this experiment, so I'm not sure about its accuracy or repeatability. I want to use them as a regular corner brackets in this position. In this case this bridge is compressed. In this position it would be pulled tensile strength, but this is what I'm more curious about. And the distance of the hook is exactly on 200 mm, and the load probably it will be 1 kg, but I'm not sure at this moment. And of course I want to measure the deformation after exactly 30 seconds. First tightening on a flat surface, so the position in this direction will be accurate. And now mounting on a vertical alloy extrusion. So what do you think about my new setup? And I think the 1 kg load is not too big for this. The deformation went to 0. Let's try 2.5 kilograms. BambuLab 0.33 mm, very stable deformation. Phaetus 0.59, Polymaker 0.38, Qidi 0.57, Siraya 0.64. Only with the Polymaker I got a little bit unexpected results, so I will repeat the test but with the same test object. I want to check the repeatability, but also to recheck this material. Polymaker repeated test. I think it was 0.39, so definitely maybe this material likes better this compression, bending, stress compared to the tensile. So what do you think about this test? Should I repeat it with similar materials and experiments? A little bit off topic, but I'm a curious person, and this is the only similar size which I have from the metal, from aluminum. It only have one hole compared to these 2 holes, but let's see how much deformation I will have with this one. Maybe not a fair comparison, because one more bolt here would help a lot, but let's say this is a real situation. I have only these corner brackets, or maybe should I use a 3D printed one? Let's see. Pause the video and enter in the comments what do you think, which will have less deformation, 3D printed or exactly this metal corner bracket. I said pause the video. First time I'm doing this, 3D printing versus metal. Oh, 2.26 millimeters. 3D printing wins. Definitely I will use them in the future. Another advantage of the 3D printing that you can scale this up if necessary. Our results one more time on one place. Layer adhesion test. Layer adhesion on open printer. Tensile test. Hook test regular and annealed. Grip test. Impact test. 3-point bending test. Corner bracket test, and let's don't forget the price. Before conclusions, this algorithm really drives me crazy. I can see the statistics that most of my viewers are those who enable that notification bell button. Regular subscribers in most cases are not even informed about my new uploads. Huge thanks to all my Patreon supporters and to Polymaker for the sponsorship. Without them, I think it would be very minimal activity on this channel. This was a huge work. Now about these materials, because they are not completely equal. I hope I could give you enough information because you have to recognize which property you need in your application. Maybe you need a layer adhesion open printer, or tensile strength, or maybe this compression bending stress is more important for you, or maybe just the price, and then you can choose the correct material for you. If you have some other experience with these materials, then write me a few lines down in the comment section. Thank you for watching this video until the end, and happy printing!